Hello, this is the genuinely approachable Sudoku for the 18th of January 2024. It is Elimination Sudoku by Clover. Normal Sudokus apply, so digits 1 to 9 in every row, every column, and every 3x3 box. If a digit appears in a cell with an arrow, so these cells have arrows in them, that digit does not appear in any cell in the direction that the arrow points. So this cell, for example, whatever digit you have on this cell, let me use a better color. There you go, darker color. Whatever digit appears in that cell, let's say it was a 3, that means that no digit here can have a 3 in there. And so a 3 here, for example, would break because there's a 3 in this direction. So those are the rules. With that, let us begin solving. So there are already some digits on arrows. This 9 and this 6 mean that along here there are no 9s and 6s. Although it is pretty... well, I know what I can say. I can say that none of these arrows can have a 1 or a 2. Because a 1 here, well, a 1 here for example, would fail because there's already a 1 in the direction. So, in other words, this rule set not only means that whatever number here cannot appear in here, whatever number in here in this direction cannot appear in an arrow that is pointing to it. So the rule set is more like a two-sided thing. It's like an if and only if. So that might be useful. In fact, we can tell you just those 3 digits now, which are 7, 6, 7, 8. Sorry, 5, 6, 7. Which means that 5 and 7 do not appear in these directions anywhere, because wherever the 5 and 7 is will point in this direction. So 5 and 7 must appear on the outside and forms another pair. Here we have 7, 8, 9. And I guess this can't be 7, because 7 must be in one of those cells, which we'll see that. And in fact, yes, here we have 7 and 8, which are not allowed to be in those cells. So here we must have 7 and 8, which means that this cell can't be a 7 anymore. So we just did a full turn, a full circle. Now I can tell what these digits are because they must be 3, 4, and 6. But this now can't be 3, 4 because, as we have already said, whatever is in this direction cannot appear in this arrow. So this must be 6. And so those can't be 6. Here we have, I think, 1, 2, and 8. So yeah, this cell C is 1 and 2, so it can't be 1 or 2 and must be 8. I guess you can also tell by these 2 digits here. So slightly unhelpful clue, but you know, it is what it is. Okay, we could probably do some regular Sudoku here, I think. Not sure, we might still need the arrows to help us a bit. I mean, these 9 see those cells and this 9 sees that cell. So 9 is in one of those cells. But that doesn't really help us much. We can do basically the same for... we can do the same for 6s. So 6s can't be in those cells because of that 6 and also because of this 6. So 6 must appear in those cells and therefore forms a 6-9 pair. Oh, this 3 sees that, so that's just 4. That's just 3. Nothing sees those, and... well, this 5 sees that, so that's 7. That's 5. This 7 now sees that, so that's 8. That's 7. This digit is 1 or 2 to complete the row, but can't be 1, so it's 2. That's 1, that's 2. Here we have 3, 5, 7. Yeah, 3, 5, 7. Here we count up 3, there we count up 5. And here we have 1, 4, 8. Here 1, 4 sees those cells, so that's 8. This is a 1, 4 pair, 1 sees that, so that's 4, that's 1. These both can't be 8 anymore, which means that that's 9, that's 8, that is 7. 7 sees that, and 5 actually sees that as well, so that's 6. That's 5, that's 7. Okay, we are done with a lot of the outside. This must be 7 now, so that's 5, that's 3, 6 here sees that, so that's 9, that's 6. Okay. So I guess now we can use these arrows to help us. So for example, 6s 6's are in one of those cells. And in here, this box, 6's are one of those cells. Doesn't really help us. Not really. 9's maybe? Well, 9's are in one of those cells now. Okay, this might be a bit harder than I thought it would be. Here we can help us because 9 can be in those cells by regular Sudoku, and this can't be 9 because it will be pointing directly at the 9, which is not possible. So 9 goes there. Therefore, okay, 9 is one of those cells. That forms an X-wing of sorts. That's just a pure X-wing, honestly. Okay. So... Looks like we don't get a lot of help. 2 is in one of those cells. 1 is in one of those cells. Okay, in this box we can do the same thing because 1's here, see those cells, and this can't be 1 because it would be, oh wait, no, it's not pointing at anything. Wow, wait, this could be a 1. Oh, that is really an issue. Okay. Yeah. Can't really help. Yeah, it doesn't really help, does it? It does not really help at all. Wow. Okay. So what do I do? What do I do? Do I just use other digits? There aren't a lot of other digits I can use because they don't really. I mean, I could tell you what that. I mean, I could probably tell what that digit is. Like one of these digits is probably some sort of naked single or whatever. Like this digit actually sees all those cells as well, besides just the columns and the rows and the box. So maybe with that we can help us because I can tell you that this cell can't be a 1, can't be a 2, can't be 3, can't be 4, can't be 5, can't be 6, can't be 7, and can't be 9, and therefore must be an 8. That is probably not how you do it, but okay, sure. That is really stupid if it's the way to do it, but I don't think that's how I do it, honestly. Now the 8's see everything but these cells, but this can't be 8 because it sees that, so 8 goes there. 8 must go there in this box now, and therefore 8 is there to finish off all the 8's. Okay, so that's slightly more useful. 9's? No, we already have 9's. We could do basically the same thing again, maybe with this cell now, because this cell sees all of those, and in fact actually that's pretty interesting that it sees all of those. It can't be 1, 2, 3, 4, 6, 8 or 9. It could be 5 or 7. That is quite frustrating. And then here we have, well, we have a plethora of digits here, but most of them are repeating, so you could actually have a lot of digits here. Same here. This one can't be 1, 2, 5, 6, 8, 9, 7, so it could be 3 or 4. This cell can't be, well, it could be a 1, which is already saying something. This can't be 1, 2, 4, 6, 7, 8, 9. So it could be 3 or 5. Here we can't have 1, 2, 3, 5, 6, 8, 9. So this could be 4 or 7. Oh, it can't be 7 either. So it can't be 1, 2, 3, 5, 6, 7, 8, 9. So it has to be 4, this one. Okay, I feel like I'm cheesing this. This can't be... That's now 4. And to finish the... well, 4 is the only place you can go in this box. This makes this now a 3. So this can't be 3, because otherwise it still would see that. So this is 5. And so this digit... Oh, is this actually... Are these actually a diagonal? Is this... Can we say that these digits must be the set of 1 to 9? I want to try proving it later when I'm done with this puzzle. But I'm keen to say that that's 1. Because it's not 2 3, 4, 5, 6, 7, 8, or 9 in the box. So it is 1. Yeah, I'm pretty inclined to say that this probably forms a set of digits 1 to 9, which I will attempt to prove later. So 4 can only go there in this box, therefore 4 must go here to finish that. Here we have 6 and 7, the 7 sees that, so that's 6, that's 7. Here we have, well, 1 must go here in this row. Here we have 5 and 9, this 5 sees that, so that's 9. Oh, not 9, sorry. 5 and 7, 7 sees that, that's 5. Here is 2 to finish the column, and that is 6 to finish the box. This is no longer 6, so 6 goes there. 6 must not be there. These digits are 3, 5, 9. 5 and 9 see that, so that's 3. 5 sees that, so that's 9, that's 5. This 9 must be here now. Here we have 2 and 3. Wow, okay. And here we have, well, 1 and 7. 7 sees that, so that's 1. That's 7. That's 5, which does make this another set of 1 to 9. This is 2 or 3. 3 sees that, so that's 2. 3, 2. This is now 3 and 7. 3 can't be there, so that's 7. That is 3. Solving the puzzle. Well, that was cool. Okay, now I want to actually see, before we finish this puzzle, I want to actually see, must these digits form a set of 1 to 9? And I think the way to prove that is by saying that this digit must be different from all those digits, and must be different from all those digits. So this digit is unique, because it cannot be any of those digits. This digit is also unique, because not only can it be none of these digits, it can't be this digit. So this digit is also unique, and by the same process, this is unique. This can't be, yes, and now we use the reverse mechanism where this digit cannot repeat in that digit, because that would break the rules, basically. So this digit can't be on the arrow and can't be in its box, making it unique as well. So all of these digits are unique, all of these digits are unique, and by like the reverse, or the diagonally symmetrical argument, these digits are also unique, which means that all 9 digits are in fact unique, and therefore must be different altogether. And so yeah, in fact, that these arrows do force all these digits to become the digits 1 to 9. So if I realized that earlier, I probably could have used that to help me. The fact that these arrows basically form some sort of X here. Alright, well, that was fun. That was a lot of interesting proving. I hope you enjoyed this video. I will see you next time. Bye bye.